Go on vacation for 2 days and TikTok puts out a React Native killer? Are you kidding? Lynx actually does look really cool though, and it's not just a React Native alternative. There's a lot more going on here, from their new build tool to their runtime to the ecosystem they're starting to form around it. This is kind of an artifact coming out of the RS build world, but it goes much deeper, and it is genuinely really cool what ByteDance has put out here. And I can't wait to explore it all in detail with y'all, because I haven't got to play with it just yet, so stay tuned if you want to see me figuring this all out with you from the bottom up. I'm not on TikTok, so I'm not being paid by them. That said, we have bills to pay, so a quick word from today's sponsor, then we'll dive straight in. Unlike most of my sponsors, this one's actually planned for this specific video because Zephyr are the industry experts at doing at-scale application development, be it websites or mobile apps. They call themselves the only sane way to do micro-frontends. A fun fact, I actually wrote the copy for them a while back. The point being, they really get stuff. I've been talking to these guys forever. Some of my favorite people from the community work at Zephyr now and are building incredible things. What am I talking about? Incredible things. Micro-frontends aren't incredible. Imagine if any person at your company could have their part of the application be its own package, and when they make a change to it and it's ready to go, that one part could be deployed separately from the rest of your app. The next time a user goes to that part of the app, it just has the latest version. Now imagine doing that at the scale of thousands upon thousands of engineers, hundreds of teams, hundreds of features. It's not fun to do, especially when you're trying to get mobile working as well. Not only do these guys have all of the expertise to do this right, they already are in production for a bunch of big companies. And they figured out how to do this with everything from React Native to the new Lynx stuff we're talking about today, to obviously modern web apps and frameworks too. You can almost think of these guys like Vercel for micro frontends, or Vercel for when you have a business that's trying to scale to thousands of engineers. If you're not already exploring micro frontends, I'll be honest, I'm a bit jealous. They're not easy to adopt, but when you do end up needing this, you do have a bunch of different teams with varying needs. They're the best way to get started, I promise. And it really is as simple as your experience with Vercel, by the way. I'm not just saying that. One command to get it all set up. They also, by the way, are some of the biggest contributors to tools like RSPack. They get module federation. They're deep in this world. And I still can't believe this is real, but it is. Since you don't have to update all of everything whenever a change goes out, you're just updating the thing that is different. 0.3 seconds is the average time to deploy on Zephyr. And you can deploy to almost any cloud with that too. AWS, Vercel, Cloudflare, and many more too. These guys are the ones that you should be talking to if you're trying to scale the development team for your apps. Take my word for it, they know what they're doing. Thank you to Zephyr for sponsoring today's video. Check them out at swaydev.link/Zephyr. So first, before we go any further, we should ask the most important question: why? Why would we want a React Native alternative? Isn't React Native already really good and performant? Yeah, but it has some catches. So, React Native has gotten really, really good, especially with the changes they made to the bridge in the JSI thing, whatever they call it. The problem previously was that React Native had its good old big single-threaded JS queue, which is the tasks that the JavaScript has to do. We also have the native layer. As we all know, native apps are blue. So let's say you do something. You touch a tab, like one of those little icons on the bottom of the app. This touch event has to be sent over to that JavaScript queue. That JS queue now has this event in it. It has to do something with it. So when it processes the event, it creates new work that it has to do, like change tabs, fetch data, and whatever else has to be done for this UI update to happen. Each of these is then going to have to change the UI state. You know, the fancy, we got like app, and we got our like sub elements, like the tab bar or whatever, not else. Once it's updated its virtual tree in this world, when the tabs change, then it gets this update state that it has to send back over to the native layer. And this, despite all of the chaos that it seems like it is here, isn't actually too bad, because the hard work is mostly happening in the native layer or in asynchronous events that are non-blocking here. So like the fetch data gets thrown off to the async queue, so it's fine. But the UI updates all have to happen in this JS queue as things that are triggering in the native layer. They've made a ton of changes to make this more efficient over the years. In particular, the JSI allows them to share memory between these two places, which can make it significantly faster. But there are still certain things where it doesn't feel great. Like when you type in an input, each key press, each letter being added or removed has to get thrown onto the JS queue as an input event. And each of those has to be processed. And if you're also processing other things in this single-threaded world on a device that's not particularly powerful, especially like an older Android phone, and it has to prioritize the input events over everything else it is doing, send the change down over to the native layer. Hopefully it gets there in time. And if it doesn't, you get the awful sticky keys experience. It's not great. The interesting thing that they did with Lynx is they built their own runtime that behaves fundamentally differently. Instead of having just one thread, there are two. Not multi-threaded in the proper traditional sense where any process can go into multiple threads. Instead, they have framework thread and they have the UI thread. This thread is effectively the stuff that you as the developer write, and the framework, which is the part that does the updating on each side, is fully separated out so that the updates don't have to block whatever else you're doing. So if you're fetching data, you're processing inputs, you're doing anything else on this side here, it doesn't have to block the framework being able to update the UI. And by separating it out like that, they're able to do much more heavy like data processing stuff while still updating at 60 FPS with no issues or lag. It's a very specific need that they've solved in a pretty cool way. And there are definitely ideas here that we might be able to take back to the React world. If you're wondering why the React team hasn't done this, it's because you can't do this in the browser, like at all, really. This is not a concept, like you can spin up a worker, but workers have to go like over a bridge in order to update the UI in the browser. So it's not like you can just spin up two threads in Chrome and have it behave similarly. The fact that they own the runtime because it's embedded in the app is what lets them be as flexible as they're being here. Think of this less like how React works in the browser and more like how React works in Node, but it's also not even React specific. There's a lot of fun here. We need to start diving in. I've given my preamble for long enough. As they say, you can write once and render anywhere. I'm very curious how their web layer works due to the multi-threaded engine that they built. I'm assuming they just can't run that in the browser, but only one way to find out. There's actually a lot of ways to find out. Anyways, performs really well. They've been using this for a bunch of their apps, so it's not surprising. They're obsessed with performance over at the ByteDance world. They want their apps running perfectly fine on every device, including a bunch of really old, poorly maintained Android phones. So performance is top of the mind for them. Interesting. The two-column waterfall is actually a really difficult thing to code, especially on mobile, so it's pretty cool. They have this all in that state. It is worth noting that unlike React Native, their layer binding to the native elements isn't React specific. I probably should explain this a little more because people seem to not get this with React Native. If you have technology like Flutter, this native layer thing doesn't exist. The way Flutter works is they're rendering a game engine effectively on top of the mobile APIs. If you're a web dev, this is kind of like a page that's implemented in Canvas or in Flash, where you're not using divs and elements from the browser, or in the case of native, you're not using the native buttons or tabs or notifications. You're building a full engine that is meant to simulate all of those things. That's why I hate Flutter so much, because it's not actually a native application platform. It is a game engine that is disguised to look like mobile applications. And that's why they always have that weird uncanny valley feeling, because everything from how the scroll works, to how the text renders, to how alignment works inside of inputs, they had to roll themselves. And that's why the kerning on fonts has been broken for 8 years. That's why accessibility is a big open question mark on Flutter. That's all because they're refusing to use the native platform. It's funny because the Lynx guys over in the ByteDance world did actually use Flutter and explore it heavily for many projects. And they threw it all away in favor of Lynx because Flutter is not good for building native applications. But when you're using something like React Native and you render a button, so if this element here is just button, that is rendering a native button for the native platform that you wrote the code for. So if you have a React Native app and you render a button on Android, that will be a native Android button. If you use a tab bar, it'll be native for all the different platforms because those platforms provide their own native UI kits. It's like, imagine you're using a web framework and you render a div and it renders some weird version of a div inside of a canvas. You'd be like, what the fuck? React Native doesn't do that, and Lynx doesn't either. The catch is that with React Native, they had to build all those bindings to all of those platforms themselves as part of the React Native layer. And a lot of alternatives to React Native, like what they have over in the Elixir world, what they had for the solid JS React Native alternative, all of those are just React Native wrappers that call the React Native bindings because that was really hard to build. The Facebook team has had like 10x more engineers working on React Native than React, and the results are incredible. You can do awesome things with React Native. But now that you know why these tools are cool, because they're not just rendering a web view, they are actually rendering native code. Let's dive in. A lot of this is RSPack based. The RSPack guys, if you're not familiar, have been trying to build a Rust-based Webpack alternative for giant code bases like what they have at ByteDance. Let's do Lynx demo. TypeScript. Interesting to have Biome as the recommended like top level linter formatter. I don't have it installed, so we're going to just do ESLint in Prettier. Lynx demo, npm install. So you guys know I like to commit everything right at the start. Starting point. Imports app CSS. This is one of the more interesting things Lynx does. It lets you use CSS even though it's native, which is a very, very interesting way of doing things that we will be diving into momentarily. Got the alter logo, use effect. Interesting. Background only. This is very interesting. This is kind of like use client, use server. It's a directive, but it's a directive that is telling the Lynx runtime this should only run in the background. Very interesting. Let's run this guy. I need to scan the QR code. It is null. So main.lynx.bundle. That's not what I want. I think I need to install the Lynx app. You'd think they would like tell you that part. Scan with Lynx. App Store. And not finding it. There's a lot of apps named Lynx. When you search Lynx ByteDance, nothing comes up. Great. Wonderful start. They only provide pre-built binaries for the iOS simulator. Okay. Looks like we're going to have to set this up by hand. I love Xcode and Apple's developer ecosystem so much. It's great. And the reason we're all putting all this effort into building alternatives to all of this is because Apple's ecosystem is so good that we all just want to use it as much as possible. Because some of you guys struggle with sarcasm, let me be very clear. A lot of these tools exist because iOS dev is such a shit show. Yeah. Now you have to wait for it to verify. You know, verify its own thing. Okay, well, we're waiting for all of this to take its freaking time. Let's explore more of what makes Lynx special. Lynx defines content and structure using a markup language, with the most basic unit being an element tag. Concept of an element tag similar. Interesting, they use lowercase special tags. View, text, and image. Very interesting. Do you have to import those? You don't have to. Very interesting. So more things you might not know if you're not a React Native dev. When you're writing React Native code, you have to import things from React Native because these lowercase helpers aren't real things. See these divs in this React code? These aren't real. Those aren't actual divs. If I command click, you'll see this brings us to the React type package. But what this actually binds to is the React DOM package. When you call something like this with a lowercase, that is a traditional HTML element, the React bundler will resolve this as effectively React DOM.div. This is how React handles this syntax because all JSX is a way to call functions. And the function being called when you write div is React DOM.div. Our editors are now smart enough and the other tools we have are good enough that as a dev, you don't really feel that. You just write a div or a button or whatever. And that's effectively what it comes out to. You don't have to think twice about it. But when you dive a little deeper, what you learn is that these aren't real. We're not rendering a div. We're rendering a function. The function's being called with the params class name as well as the param children. And now it becomes a div in the browser. React Native doesn't do this because there's no such thing as a div on mobile. On mobile, you have different native primitives. So React Native is an alternative not to React, but to React DOM. React DOM is the package that turns this into a div. React Native is the package that turns Vue into what it would be for the native app. But since it's so different, React Native requires you to import those things. You'd have to like import view, button, touch, or touchable opacity from React Native. And these are all things that React Native will bind correctly when you use them as JSX. It seems like the decision made by the guys over at Lynx was a hybrid between the two, where this looks kind of like writing normal React, where lowercase view, text, and image are kind of like writing those normal things, and you don't have to import them. They've made them globals similar to how React DOM works. Seems like nice DX. Simulator. Okay. That appears to have worked. This verifying step appears to have not. Oh no, my IP address leaked. Whatever will I do? Wait, is that it? It's already ready? I'm too used to Expo and React Native. That takes a while. And now we can play. So if I go change things in that CSS file, if I change this to be blacker. Yeah, I hit save now. Yeah, that's that RSpec experience, the instantaneous hot reloading. To be fair, React Native's gotten pretty good at that as well, but yeah. Subscribe, you nerd. Saving now. Saving again now. Yeah, it's effectively instant. Interesting. See this main thread? This is where Lynx gets very different from other alternatives. Main thread : easing. Very interesting. How does that work? Weird that that's not typed properly. Might just be a different version or something, but screen width should, I guess, be a global prop you can access for things like knowing how wide the screen you're on is. That's actually really nice. Use offset. This is one of those things that's so annoying to deal with like keyboard inputs and stuff, to have an offset for like this touch bar on the bottom to make sure you're not covering it. I can't tell you how many Flutter apps I've used, and I could immediately tell because the buttons were too close to the bottom because they weren't using offsets correctly. These main thread bindings are really interesting. I want to go read more about that before we dive too deep. So handle touch start xref.current, e.touches, client x, handle touch move. This is how much you've moved. Bind touch start and bind touch move. All are part of view. And we have an offset here, which is done in a ref, which is interesting because a ref shouldn't update the UI, but I'm sure they have a fix for that. Update swiper offset. Interesting. So on the touch move, they also call this update swiper offset. And they're using node manip. Okay. There's the key difference here. This is not very React-y. Generally speaking, the way that React encourages you to think is that your state generates the UI. So when a component has some state, like how far scrolled it should be, the component owns that state. And when it changes, the component itself updates and renders the new UI. This feels a lot less like that and a lot more like something like React 3 Fiber. In React 3 Fiber, you'll bind refs for the elements you want to change, and then you have a use frame call. And this use frame is what does the update on the ref. So you don't keep a state that is your current rotation or values like that. You have a use frame counter that updates it. And this ref is what determines what the UI is showing, not the state. Normally when you write React, this would be a use state call. And when it updates, the component would rerun and trigger a change to this return. But that means you have to run React on every frame or every change. And every delta when you're moving your thumb left to right, you don't have to rerender the component during that with this model, which is really cool. Same here. Once you run this box function once, it doesn't have to rerun unless you pass it different props. The use frame will update this ref, and when the ref changes, the element will change as well. So it doesn't have to rerun top to bottom. It's almost kind of like signals, but they're not tracing the actual change. You're directly making the change. Almost more like a jQuery style where you select the element and you update its properties rather than the React model where you change some state and all of the new properties get emitted out as a result of that. Very interesting to see this here. This does really show that they're like trying to get the ergonomics of React, but the performance of other things. React Native has historically steered away from these types of things. There are packages that enable it though, like React Native Reanimated does a lot of these things under the hood for you. People in chat are already linking the tools like that. In React Native, they do have something like set native props, which allows you to update things without having to rerun the component. So this use callback call here will update the native layer for this text input to have different data in it. So this will change the text, edited text, when you hit the edit text button, the touchable opacity, which is basically a button. So when you click that button, it'll update this without having to rerun the component. That said, not the most common thing to do in like user React Native code. This is more something that the libraries would do for you. And tools, again, like React Native Reanimated, do for you really well. very interesting to see it as like a recommended primitive in a framework instead of it being a workaround when you need it. Yeah, you can also make custom hooks. I'm assuming that's what they're going to show here. Yeah, update swiper style, swiper container ref comes from this use update swiper style. Oh, here's the hooks. Yeah, touchable start, touch start current offset, all refs for different numbers, and then it calls the on offset update function that it gets passed in order to trigger the update. And here we have the update swiper style, which is the other hook. And this one is what does the transformation. That's a lot of code for what could have just been a useState call, but that useState call would have to happen on the main thread that is actually triggering which elements are rendering, and not the dynamic behaviors. And that's, again, like the big difference here is in React Native, if you did it the normal traditional React Native way, the work that you're doing to determine which elements to show and what props they have is being blocked by the work for when you're sliding left and right. All of those are fighting for priority in the same queue. With Lynx, these can be separated out entirely. So the elements being rendered can be handled by the framework thread, and the rest can be handled by that other thread. You may have noticed that sometimes the scrolling doesn't feel smooth. That's because touch events occur in the main thread, but the event listener code is running in the background thread, which causes delayed touch event responses. It's particularly noticeable on low-end devices. But you can use a main thread script to optimize the issue. Yeah, so here it's binding on main thread instead, which is very interesting. So I'm guessing that means these guys also have, main thread for these interaction handlers, so that these all happen on that main thread and not the background slower thread. If I've learned anything from my time in the mobile trenches, it's that you have to care more about all of these things to make a mobile app feel good. It doesn't matter if you're using Flutter or React Native or Cordova or even just native tools and technologies directly. You have to think about these parts to make a native app feel really good. It's weird that you as a dev have to think about what should or shouldn't be on the main thread, but it's a lot better than the alternative of everything's on the main thread, so now there is no threading. I really like the idea of by default things aren't on the main thread, similar to with like server components. By default, the component doesn't ship JS. It is the optimal thing to have your main thread not blocked by stuff like a giant data fetch or a connection to a WebSocket client or those types of things. And I really like the idea that by default, your UI isn't blocked by all of these other things. But if you do want to prioritize your work, you can tag it accordingly. It is kind of wild that you can prefix a prop like this to tell Lynx, hey, I want this on the main thread. Never seen this pattern before for determining like threading characteristics in the definition of props. Almost feels kind of like viewy in a way. So how do we communicate between the threads? That's a really good question. Tell me all about this. We want a progress indicator to show which page you're on, but it has styling, but it lacks the progress updates. So let's see how they do this. Main thread calling background thread. Indicator component, which accepts a current prop indicating the current page. You need to update current when scrolling. On index update, take the new index. Main thread and background thread functions need special APIs to call each other. Here is where this whole model starts to fall apart. Now, because these two threads are running code in different places, you can't just call functions between the two. We're not in a competent language like Elixir. We're in JavaScript. So these relationships have to be handled by you. So if you need to call something on the main thread from background, you have to call run on main thread and vice versa. It is nice that they have these helpers. So run on background, index update, index. I also like that this kind of makes it very explicit when you're calling things from different threads, because you shouldn't have to do this too often. But yeah, interesting. Background thread calling main thread. Useful progress indicator should also support clicking to jump to the corresponding page. It is also interesting if you think about it that like a user interaction like a touch or a slide and a scroll, you get to pick which thread those interactions are handled on. That is a very interesting paradigm the more that I'm thinking about it. Interesting. Very interesting. The main thread functions can use background thread values. By default, if you have a main thread within, I'm assuming, some type of closure or scope relative to the background values, those will automatically get passed in so that you can access them, and that those main thread functions now can depend on those things. But it has limitations. The background thread values must be serializable, So you can't use functions, promises, and other non-serializable values. Very, very interesting. If you understand how workers work in the browser, you're a very small niche amongst JS devs. So for everyone else, so when you spin up a worker in JavaScript, you go to T3 chat and ask how to do it because the syntax is weird. You create a worker with a specific JS file. That file now has a runner that you'll see here, like an on message that it exports for how it handles the message. And Gemini Flash's syntax highlighting and formatting is entirely broken. So we'll rerun this with a model that it won't be as broken in. Cool. So on message, we have this handler. On error, we have a handler. And worker.postMessage is how we pass values to the worker. So when you spin up a worker in the browser, that's a different JS thread that's running different JS code. You can't just pass it a function to run. You have to instantiate the worker with different JavaScript and then post messages to it. And these messages being posted back and forth need to be JSON serializable. So here we've received the event.data. We have the original value, the processed value, and the status that we are sending back as a post message that then the other side can receive. But we're passing these back and forth as messages, not as us calling back and forth. Lynx makes it feel different by letting you call things with those background thread and main thread helpers. But you can't just pass a value over. You have to make sure the thing you're passing can be handled as a message, because under the hood, it probably works very similarly. But that's the thing with threads. It's not just, oh, take your code and run it multiple places. When you're splitting data between threads, you need ways to pass the data between them. And that's where all of this becomes significantly more complex. And apparently, you have to do the same thing with reanimated. They have a run on JS, which lets you run non-workletized functions that otherwise couldn't run on the UI thread. It's been time to remake Twitch and React Native for like 5 years now. More than that. I did it 5 years ago, but yeah, we'll see if they ever ship a good app or care enough to figure that out. Anyways, background thread or past main thread values. Main thread easing prop to swipe, allow users to customize the animation curve. Main thread easing is the ease and out function. Runs on main thread. The function ease and out is past the background thread hook, use offset. Interesting. So this is a main thread function that we are passing as a prop and allowing for a background thread hook, use offset to call. Yeah, MT easing, that's a main thread call that we're making from background thread. And then use offset, it's passed to the main thread function animate. Very interesting. Main thread values can be passed by background thread, but not used. So these main thread functions can be passed. So you're passing this around. We're not actually calling this here. We're passing it to use offset, where it's then called in main thread. That's very interesting. We're taking this little box of code that runs in the main thread, and we're passing the reference to it to background thread, where we can't call it, but then accessing it in main thread again, where we pass it to something else. That is really interesting. My biggest hesitation with all of that is that it makes type safety not useful, because there's no indication when you're working in here that I can't call MT easing. But again, this isn't for us mere mortals to do a whole lot of. This is to make sure everything can be as fast as possible. And my guess is most of the time you would probably just write everything in background thread. And then when you have specific things you want to optimize, someone who deeply understands the system will come in, do the right main thread calls, and optimize your app at that point. There isn't really a great path for that type of like latent optimization in React Native. If you don't start with reanimated and use it properly, it's rough. But here, you can kind of just do it later, which seems really powerful. But it would also be fragile in the sense that somebody who isn't as familiar with these properties would get really confused because they see this function being passed all around the code base. And they're like, you know what? I want to set a default value here. So they do optional main thread easing, and they give it a fallback that they define right here for different values. And that fallback fails because when it does get called, it was defined in background. So it tries to call a background function, which it can't do, and then it fails. So there's like a lot of those little unexpected edge cases people will run into when they're learning this. And since the type system can't error out when those happen, they have to run into it in the runtime to see the bug. I would be more okay with like either of these cases, where if it was confusing but it type errored, or it wasn't confusing, but it only runtime errored, I'd be okay with both of those. But the fact that it is confusing, it causes runtime errors, and it doesn't have a type error, that combo is uniquely brutal for onboarding. And the only reason you would commit to something that has those like catches is because you really need the performance wins. Yeah, this is a really good tutorial in the sense that it like brings you through all of the chaos of how this multi-threaded stuff works here. I should probably read their actual blog post, specifically because Juan is one of the people leading the architecture there. If you're not familiar, Juan's the dev who did the original React compiler presentation. So there aren't many people who understand the depth of React performance quite as well as he does. So it's very exciting to see him as involved in this project as he is. Lynx is a family of technologies empowering devs to use their existing web skills to create truly native UIs for both mobile and web from a single code base. Designed for diverse use cases and rich interactivity, Lynx delivers vibrant and engaging UIs for large-scale apps like TikTok, featuring a speedy and versatile rendering engine, performance-driven dual-threaded UI programming, modern Rust-based tooling, and more. We deeply appreciate all the prior arts that have shaped the field of cross-platform dev, aspire to contribute to this movement by open sourcing Lynx today, inviting more devs to build applications with more freedom and productivity. For the generation of digital natives, mobile phones and the apps on them are their first digital experiences. For these app-centric users, a non-native experience isn't just inconvenient, it's a red flag. I totally agree here. You can tell when something isn't using native tech so quickly, especially if you use apps every day, especially if you use iOS. I struggle to believe people who say like when they use a Flutter app, they can't tell, or when they're using a Cordova app, like the person was just shilling earlier, you can tell. It feels bad. And it makes people less likely to engage and re-engage and keep scrolling through your app and using it for hours at a time. Those small frustrations don't work if you're not being paid to use the app. There's a lot of things I use where they are inconvenient in that way. Things like Stripe, things like random dashboards and GitHub. But those are all tech that I have to use. I don't have an alternative, and I'm being paid to use those solutions. Something like TikTok, if it's bad, I just move over to Instagram or YouTube. Or if I get frustrated, I close the app and go somewhere else. It's a whole different war, and they are fighting it hard. Things like blank screens, 0.1 second lags, and a like animation, or unfamiliar UI patterns can all make apps feel cheap or untrustworthy. We believe that native primitives and responsiveness aren't just nice to haves. Native is a necessity. This is why they moved off of Flutter. Despite the rapid growth of the app economy, delivering such experiences at scale and velocity remains to be a challenge. This is a huge piece here. I haven't touched on it yet, but one of the most important parts of why all of these things matter so much is distribution. I have this app, I built it on my computer, so I have this bundle. I want this app bundle to be on the App Store so that people can install it. So I have to take this bundle, build it, sign it, all of that. I'm not even going to include that in this part. I have to send it to Apple. Now Apple or Google or whoever you're distributing the app through has to approve the app. And once it's been approved, it can now be on the App Store. But even that's not so simple. So we'll call this Apple Review. So once Apple's reviewed it and approved it, assuming they do it once, which big assumption, now it's on the App Store distribution. Fun fact with App Store distribution, you have no control over when users actually get your updated app. You do have some toggles, but a lot of users just have auto update off. So when does this distribution actually make it to the user? The first time, it makes it to the user's phone when they install it. So when a user goes to install the app on their phone, they just get whatever the latest version is. But if we're pushing an update, like we have now, My App V2, we have no idea how long it's going to take from when I send this to Apple for review for that to be the version that is on the App Store and most importantly is pushed out. And my users, for any amount of time, could be on that old version. Like whenever it's just a known fact that when you push a major update to an app, a large percentage, like sometimes 20 to 40%, will be on the old version for weeks, if not months, because the binary has to be loaded from Apple, and Apple is the ultimate decider in if and when the distribution goes out, and you have to hope the users have automatic updates on. There are some solutions here. You can have the app hit some endpoint that checks if it's the latest version and yells at you if you're on an old version and makes you go install the update. Not great. Wouldn't it be a lot better if, for at the very least, updates that weren't massive, I could just do this? So you install whatever the latest shell is, but new changes that are like quick UI fixes or additional features being added that aren't necessary for code review or review from Apple as a whole, If I just want to fix some bug or add some theme for a holiday or add a new category option in the picker for searching, those things shouldn't require app review. And it's not like they do require app review either, because people already do all of this through server-side control. So they'll usually have, instead of like your search experience having a list of 4 options that are hard-coded, it'll fetch all the valid options from the backend. Instead of the theme being something that's hard-coded into the app, it might be fetched from a set of options on the backend. We're already doing this, but we've also been forced to separate all of this logic out in order for that to be possible. If it was possible for us to ship something a little closer to that native binding without having to go through the App Store, that would be a huge win. That's what this is. This is sometimes called code push, sometimes called over-the-air updates. There's a lot of terms for this workflow. The point is that if you don't need to change the native bindings, like what view or what touchable opacity become, we shouldn't have to wait on Apple to let us make those changes. We shouldn't be forced to re-architect the entire way our app is built to pull every piece of state from a server so we can toggle these switches on the server side without having to go through app review. The idea of server-driven UI, where this code that becomes your UI has to come from somewhere other than Apple, is a dragon we've all been chasing in the applications at scale world for a while. And making something that handles that well, but also performs well, is really hard. Because if we offload all this to our servers, we're now blocking everything on server calls. That sucks. If we make it all native, we're now stuck waiting for Apple to approve, which means we can't actually ship fast, and that sucks. And that's why the scale and velocity call out here is really important, because they need a solution that works for apps the size of what they build at TikTok and don't have to wait for 1/5 of their users to get the update. But they also need the velocity where they can ship really fast and make changes really quickly and get them to their users really fast. And that's a unique balance that most companies have had to roll their own in for a while. Tools like React Native and Expo have helped a bunch, and Lynx is seemingly going even further. And I know for a fact they built this way because they're doing all this stuff with RS Pack and, most importantly, module federation. Now imagine if instead of our app bundle being just my app, imagine if it was a couple different things. Imagine that this bundle, it's still my app, V2, but V2 has different things in it. It has the store view V0. Cool. So we have this as one of the things in our bundle. We have React V19.0.1. We have some SVG loader V1.14 or whatever. We have the item view V0. You get the idea. Your app is made up of multiple of these things. Some of these might be by different teams with different goals and purposes. If only one of these changed, the magic of this pattern is you can just send the one that changed and not have to nuke and reload everything else. Each of these bindings, each of these submodules can be owned by different teams and sourced from different links. So the app can now download the latest for each part and not have to update the whole thing. Really, really cool stuff. I want this so badly for T3 chat because 99% of the code that you're downloading will never change. Things like our math renderer are 0.5 MB of JS because they have to be. It's complex rendering LaTeX in the browser. If I could just have that be a static module that's never reloaded once it's loaded, and all of the data that gets fetched when you update is just our user side code that we wrote, that'd be awesome. But setting this stuff up sucks. And that's why the industry leads of it are working over at ByteDance and TikTok to make this all happen. We believe that by enabling developers to build once and reach more platforms, we can deliver joys for more users and faster. TikTok is known and loved as a mobile-first platform, continuously bringing innovative and engaging experiences to diverse and dynamic users around the world. That feels like copy written by ByteDance. Lynx now powers an extremely wide spectrum of surfaces, from the high-frequency search panel to the full-fledged TikTok Studio app, from complex e-commerce storefronts like Shop that demand reliability and trust, to highly engaging experiences like Live. Interesting. I didn't know Live was built with Lynx. That's really cool. They're betting heavily on it, it seems. That's everything other than the main TikTok view for the most part. And again, remember that thing I was saying about being able to do updates without going through the App Store? The only way you could do an event like the Met Gala before is you make all the native changes for it, you put them under a feature flag or some tag, you push it up to Apple for review, pray they approve it in time for that event, and then when the event goes live, you flip the feature flag on, then you flip it off, and then someday you go remove it from the bundles. But chances are there's a lot of people who have the Met Gala code installed in their phone forever going forward because you have to put it in weeks ahead, get it approved, and then hope everything goes well so you can hit the switch on the right day. Or we just go back to here. We make our Met Gala view V1 whatever. And now this is a new thing in our bundle. Now we can ship just this one additional thing. And when it's done, delete it. That easy. Really, really cool for the types of things that they are doing at scale. We believe that scale and velocity mean much more than just applying a feature, bug fix, or optimization across all platforms to improve cost efficiency. It also means the versatility to adapt the same shared technological foundation to a broad spectrum of scenarios without the need to build new teams or reinvent the wheel for every unique use case. Whew, bangers. Ooh, this is a fun section here. The web platform was historically created for documents and then gradually evolved into a dev platform. Yet it continues to face constraints that slow down its ability to adapt and innovate quickly. Shipping web technologies for cross-platform dev has become a defining norm in the industry. Since 2008, PhoneGap, later known as Cordova, strived to keep the web as cross-platform as possible by augmenting web views with native capabilities. In 2015, React Native's 10 years old now, that's wild. React Native pioneered the idea of bridging native UI with web tech, enabling declarative UIs with React Mobile. And that same year, Flutter, with its web heritage, adopted a similar declarative UI model and introduced a new approach using a custom rendering engine. Lynx followed a similar spirit. You could think of it as an alternative web tailored for app dev. It aims to honor the assets of web technologies while taking an opinionated approach, supporting web-like APIs and adding constraints and extensions with clear intent. To illustrate the balance, let me share two examples. One where we choose to follow the web, and another where we intentionally make a difference. Craft designs with markup and CSS as usual. So here we have view, style, flex direction column, background, radial gradient. Doesn't look great, but that's because I'm in Firefox. Text, all looks very traditional CSS-y. At its core, UI technologies exist to deliver exceptional product design. Lynx embraces the familiarity of web dev, allowing devs to write markup in CSS just as they would for the web. Lynx natively supports CSS animations and transitions, CSS selectors, and variables for theming, as well as modern CSS visual effects like gradients, clipping, and masking. Kind of wild. They basically had to re-implement all of that natively. I'm assuming that's how that works. I am very curious because, again, it's not a web view. So they probably had to re-implement all of this core CSS stuff so that it works in their not a web view. But then separately, they have the second example, which is using the main thread responsibly for interactivity. One of Lynx's most notable architectural decisions is its statically enforced division of user scripting into two distinct runtimes. The main thread runtime, which is powered by Prism, and which is a custom JS engine specifically optimized for Lynx, which is dedicated to privileged synchronous UI tasks like initial launch and high priority event handling. Separately, there's a background runtime, which is the default for user code, which ensures the main thread remains low workload and non-blocking. This enables two killer features. Instant first frame rendering. This is really, really cool. One of the few things you will definitely notice with React Native apps is they have to have that little loading view there when it spins up the JS to command the UI. But with main thread scripting, you can now instantly start rendering. Actually, no, this is still with the IFR. Interesting. Surprised they have the loading state there. They should be able to make it way... Yeah, that's basically instant. That's just the app icon open. Normally with React Native apps, since it takes some amount of time for the runtime to spin up, you're in that loading screen for quite a bit longer. Here, it's effectively instant, and I think almost all apps will have that. The React Native team was working really hard on Hermes as their solution for this, which is a custom runtime that does the ahead of time like JIT compilation for the JS code, so it can theoretically launch faster. It's a lot better than it would be if it was still just V8 based, but it's still not quite as fast as what they have done here. And by separating it, they now have way less code that main thread has to care about. And that main thread can be optimized using Prism, which is, again, a custom runtime that they built specifically to be as fast as possible for launching your app and handling those interactions. Prism is built on top of Quick.js, which is, again, really, really fast JavaScript runtime. Quick.js is built to be fast and tiny. 210 kilobytes of x86 code for the entirety of Quick.js. It obviously means there's a lot of things that we expect from especially runtimes like Node that you won't get in Quick.js. But it also, more importantly, means you can spin it up immediately because the memory footprint of that is nothing. Sorry, did I say Prism? It's Prim.js, my bad. The key features for Prim are an optimized interpreter, which allows for the interpretation step where it takes the code and figures out what to do with it in the first place to be much, much faster. Seamless object model integration, so allows for reduction of data communication overhead and improving rendering performance between this main thread, the background thread where your code runs, and the UI itself. That's the native layer. They built their own model to bridge between all of those. They also built their own garbage collector instead of QuickJS's reference counter, which allows them to not clean up memory as aggressively and not have to block on every interaction. Instead, they clean up later on, which allows for better performance, improved memory analyzability, and a reduced risk of memory leaks. Cool. They also fully implemented the Chrome DevTool protocol. That's huge, actually. That makes it way easier to debug. Debugging seems excellent. Okay. Oh yeah, that's really good. If you're not already familiar, debugging in React Native is one of the biggest arguments against it. And this just solves it because you have the full Chrome DevTools just there. And you can even look at, oh, that is really good. That's really good, actually. They have a desktop app that lets you run in that view there and actually see what elements are what. This is one of the biggest gaps that's missing in the React Native ecosystem. This might push me over the edge to use this for stuff. That is super cool. Apparently, you can even bridge between your iPhone or whatever is running the app to do all of this. Oh, man. The contours of the React Native experience. What do you mean? You don't like Flipper? Wait, doesn't RN also have Chrome DevTool support with Expo? There's the problem. We've been stuck with Flipper for so fucking long, and I'm not even sure of the state of the Chrome DevTool stuff with Expo. As far as I know, you have to be using the WebView stuff for that. You can't use the Chrome DevTools with Expo with an app that's running on your phone. And even if you can, I don't know how much I trust that binding layer. It's also cool that ByteDance isn't just releasing one piece of this. They are releasing the whole pile, the Lynx family as they call it, including Lynx, React Lynx, which means you could build something that isn't React if you want to use Svelte or Solid or Vue or whatever else with it. RSpeedy, which is the build tool built on top of RSpack for setting this all up. The Lynx DevTool stuff, Lynx for Web, and Prim, all released together as one giant drop. Genuinely really cool. Also, Lynx being C++ surprises, hopefully, absolutely nobody. And then the Java and Objective-C and Objective-C++ parts, those are the bindings for Android and iOS. Internally, we've seen service migration from web to Lynx often achieves a 2 to 4x reduction in launch times across the board. So that's if the difference between using a built-in web view, something like Cordova or PhoneGap, to using Lynx instead, is you get 4x speed up for launching the app. Huge. Lynx was originally developed by an engineering team at ByteDance, which continues to drive its development. Significant user of Lynx, TikTok recognizes the innovation and potential of Lynx and has been making extensive use of it in a series of TikTok apps. TikTok will facilitate the open source release of Lynx, offering support in several areas, including funding, technical enhancements, community promotion, and ecosystem growth. Democratize cross-platform technologies. For years, cross-platform dev for web devs has been defined by the patterns and solutions established by a few dominant players. While we celebrate their remarkable contributions, there's growing demand for greater diversity in approaches. I agree. It's kind of sad that if you want a good mobile experience that isn't just building a really good native app for each individual platform with a team dedicated to each, the only reasonable option for a while now has been React Native. Everything else is like cool, but none of it is ready at all. Like the reason this is exciting, to go back to the dunking I was doing earlier, is because this seems like a stable production ready foundation for good native apps with also the benefits of WebDX and distribution. And that set of boxes is really hard to check. The dream set of tools, like if everything was perfect, we would have all of the following. We would have native SDK control. So we'd be accessing that native UI layer. We would have distribution without ties to App Store so that we can distribute something, probably that binary, that allows us to change parts of the UI without having to go through the whole app review process. We would have DX comparable to modern web. We'd have interop with a big ecosystem of app-focused tools. Things like React Query would have good dev tools. I'll say dev and debug tools, i.e. Chrome dev tools. And obviously, open source. Up until now, the only thing that checked all these boxes was React Native. Something like Flutter did not have a great score here. Flutter did not do native. It did not do the distribution without the App Store. The creator of Flutter actually quit Google to go try and build this externally with Shorebird, and I have no idea what the current state of that is. The other company I was talking to that was doing that stuff shut down. DX comparable to the modern web. I will say Flutter is close enough here. I won't cross it off. Interop with a big ecosystem. No. Good debug and dev tools, sure. And open source, sure. So you lose 3 of the 6 points with something like Flutter. Native apps, you get this one, and then you get none of the rest at all. React Native got you all of these. The debug and dev tools weren't good before, but they're apparently there now. As of last year, you can use Chrome's dev tools for React Native. Awesome. Haven't tried it yet. Not sure how stable it is. But Lynx is hitting all of these boxes too. And I didn't think we'd see a day where something else would do it because it just seemed like too much work to be justifiable. The way they phrase it is they're not open sourcing a single fixed solution with one open source project. They're trying to open source a meta infrastructure that enables teams and businesses that are facing similar scale and velocity challenges to build their own cross-platform solutions. We're open sourcing React Lynx, which is React on Lynx, as Lynx's initial front-end framework flavor, enabling componentized declarative UI on Lynx. However, Lynx isn't limited to React. In fact, other frameworks already represent roughly half of Lynx's overall usage, demonstrating its neutrality and hosting different flavors. As modern apps grow increasingly complex, with dozens or even hundreds of devs collaborating on a single app, Lynx ships with RSpeedy, which is a toolchain based on the popular Rust-based bundler RSpack, which enables fast builds and paves the way for a multi-framework micro-frontend future with module federation. And that means that different bundles, like if we go back to my diagram here, it'd be possible that the store view might rely on its own separate framework package, like Svelte Lynx. And now Svelte Lynx could be bundled within this store view bundle as just one of its packages and one of its dependencies. And all of this belongs in your app, but you can ship it separately. It can be updated separately and not affect the other pieces because this is just effectively the function that is called when you go to that view. Super, super cool. Not only is the core engine of Lynx framework agnostic, it's also agnostic to host platforms as well as rendering backends. Drawing inspiration from a spectrum of projects like Chromium, Flutter, and React Native, it's designed to adapt to new platform primitives, and it's flexible enough to switch to a custom renderer, enabling pixel-perfect, consistent rendering across any platform with a graphic interface. This is effectively Flutter mode, where instead of it rendering native UI elements, it's rendering a canvas that has a pixel-perfect UI, so everything looks exactly the same on all platforms, but it's not using native at all. The fact that the same renderer can do both is really cool, but you kind of have that benefit in React Native as well. In the React Native world, we already have React Native Skia, which allows you to render React Native components on a Skia canvas, which is the same tech that Flutter used to be powered by and still usually is. They're in a weird engine overhaul thing over there. Who knows when it will all ship? Anyways, this is not the end, rather a new beginning. Lynx is production ready and already powers an incredible number of businesses. What we are open sourcing today is the exact version that we use in production, which is why it starts at version 3.x. That's cool. They're not hiding and changing the version number for the public release. It's the exact same they've been consuming. It even introduces legacy code and APIs that we intend to deprecate. We believe in open sourcing what we actually rely on. That's really cool to call out. Oh boy, they're moving all dev to GitHub with this, making it open and transparent to the community. This release only marks the beginning. What we're releasing open source today is not everything. Many peripherals that we're proud of, including additional UI components, advanced built-in graphics capabilities, the custom render, and other framework stuff, have not come yet. This is the beginning of the journey because it's a relatively young team in the open source space. We know we have much to learn about working, collaborating, and growing with the community. We're glad that we took this step because we believe open source is the right path forward to foster collaboration, push the boundaries of what's possible in cross-platform development, and give back to the community that's given us so much. We invite you to join us on this exciting journey, and we welcome your feedback and contributions. This is a really good launch. I'm trying to find more holes to poke, and it's honestly kind of hard. The biggest potential issue I see is something that I mostly know of because of my experience with doing React server-side stuff with server components. These prefixes and these callouts, like in here with the main thread declaration here, these don't work great with packages. So if I have a package that needs to run on main thread, hopefully they bundle it correctly. And if they don't, you're screwed. You have to wrap everything yourself manually in all of the right layers. And if they do include these properly, that package is now Lynx specific and won't work well in other React flavors. So it's a tough balance there. My guess is that you would be writing a lot more of that update code yourself inside of the application code rather than relying on libraries for it as much, both because the ecosystem isn't there yet and because these like decorators are not very fun to manage externally. React Lynx follows React's programming model, but leverages the dual-threaded runtimes. Yeah. So your code runs on 2 threads. This will be printed twice. Main thread's responsible for rendering the initial screen and applying subsequent UI updates. This allows for users to see the first screen as quickly as possible while reducing the main thread's workload. Background thread runs with a complete React runtime, handling component lifecycles and other side effects. Since complete consistency with single-threaded React is not possible, we've modified the component lifecycle as shown in the component lifecycle page. Here we have the main thread render, background thread also renders. It's kind of like SSR, but happening on device, where there's 2 things rendering the same content. The background thread has to hydrate because the main thread finished the render faster. Hydrate, use background thread data to calibrate main thread data, triggers an apply update. Ref callback is what handles the changes there. Any effects from render will start running after all of that. Then if an update happens in the background, once it is done figuring out what that is, it sends it to the main thread to actually apply the update. Because this background thread, all of its renders don't exist. The renders that matter are the ones that it sends to the main thread that then applies the update. Yeah, very cool to see them documenting the ways that it differs from React, because it does. It's not just using React like we're used to. Their goals were to optimize first screen render. Again, funny enough, very similar to server-side rendering, where the goal of SSR is so that when you go to the page, you see something way quicker and you don't have to wait for the JS to all load in and do all of that stuff. Very cool. This does mean that they don't have certain helpers like use layout effect, which is an effect that runs after the update but before the UI change. They have their own handle layout thing that you can use similarly. Special characterizations of, oh god, list is always a challenge. List element has on-demand loading and node reuse characteristics. List elements created, all of its child components are JS object instances which are created together, but the corresponding actual elements are not immediately generated. Instead, they're created and reused only when list is about to scroll to the corresponding position. Very interesting. Back to the how it differs. Your code does run on 2 threads, but not all code can actually run on both of those threads. Consider the following example that adds a listener to the global event emitter. So we have the global event emitter, Lynx get.js module, global event emitter, add listener, my happy event, triggered. When this component is rendered, you'll see a not a function error. It occurs because while the Lynx rendering of the component on both threads, this global event emitter call cannot be executed on the main thread. So it'll have to be wrapped in a function call or something and passed. You can't just call this in body because that code has to run on both. It's again very similar to SSR. I bet that people who are familiar with server-side rendering patterns are going to be very well off for all of this. There are 3 key rules for background-only code. Okay, rule 1 is that code meeting any of these conditions is considered background-only. So it has event handlers, effects, ref props, functions with background-only directives, and modules that import background-only on top. For example, all the functions with console log in the following example are considered background-only. So here, the use effect, that makes that background-only. Function background-only is tagged background-only. And if the function or the file imports background only, that whole file is. This is very similar to server component stuff. Yeah, so if we want that event listener, throw it in a use effect. Again, just like server components. Background only code can be used within other background only code. That makes sense. Code that's only used by background only code is considered background only as well. So like bind tap here doesn't need to be marked because it's being called in a way that's background only, so it will behave background only unless you specify otherwise. Also be considered background because it's only called in a use effect. Yep, makes sense. Due to limitations to compiler analysis capabilities and compile time perf, there are some exceptions. So when we pass a prop, like an event handler here, we don't know what you're doing with your props in the custom components you're defining. So you'd have to specify this before passing it. Otherwise, it'll try to pass it on main thread as well. And when you do custom hooks, they should all be mounted as background only as well. But similar to how some code can only run there, some can only run on the main thread. Makes sense. You can mark it main thread similarly. I think I have my mental model locked in here. This is really, really cool. It's early in its release and ecosystem presence, but it is not early in its implementation. This is a very legitimate solution. This is, without question, the strongest competition I've ever seen for React Native, and I think it's worth paying some attention to. If you're interested in mobile dev and best-in-class developer experience building high-quality mobile apps, there is stuff we can all learn from here, and I am absolutely rooting on the Lynx team to figure out how to do this as best as possible. Even if I never ship an app with it or use an app using it, they put a lot of work here to push the way we build for mobile forward, and I'm seeing the results. This is really genuinely cool. This feels like a minimal method to replicate the wins possible in React Native, but stripped down to be just those bare metal essentials. And I see so much potential for what they've built here. I'm going to have a seizure if I think too much about this message, so I'm going to pretend that wasn't sent and wrap up. Thank you guys as always for sticking around for this one. React Native in the mobile world is a bit chaotic. I do mean to talk about this stuff more because it is really cool. But let me know what you guys think. Are you going to try out React Lynx, or are you just going to stick to web dev? Or God forbid, are you going to go spin up a Flutter app? Let me know. And until next time, please don't ship Flutter. Seriously, it's such a disaster. I can't believe they're pushing it the way they are. It's just like, do you not care about users with accessibility needs, or just ignore all of the work that's gone on in the platforms for years? Like, I just...